Produced by PI Media. Blockchain.
Between February 2015 and December 2016, Bitmoji, Snapchat's app for personalized emojis, saw its customer base grow by 5,210%. To grasp the sheer scale of this change, consider what would happen if a physical business, say your local coffee shop, saw that much growth in the same time period. You walk by this coffee shop in early 2015 and see, 8 people sitting there, drinking lattes and cappuccinos, tapping on their laptops, or chatting with friends. By the end of the following year, at 5,210% growth, you can expect to walk by and see some 417 people crammed into the store, spilling hot coffee on one another, suffocating for lack of space, not being able to get in and out, and the fire department outside preparing to evacuate the scene. Hi, I'm Nate Nelson, and welcome to this episode of the Orbs Podcast. The marketplace for online services can be a hugely volatile place, for better or worse. Bitmoji's meteoric rise was remarkable, but plenty of apps in recent years have experienced a similar phenomenon. Uber, Tinder, Venmo, these brands didn't slowly grind their way to success like the small businesses of old. Something clicked, and in the span of just 1 or 2 years, each one saw their user bases multiply once, twice, 10 times over. But apps aren't invulnerable to the expense that comes along with a sudden uptick in business. Just as a really amazing coffee shop might have to hire more employees and open new store locations to avoid overcrowding, app developers also have to make new hires, purchase more server space, and build out their back-end infrastructures to avoid slowdowns, crashes, and the other errors that tend to crop up when a product designed to serve thousands of people has to take on a load of millions. An effective blockchain platform for the consumer app industry must be specifically designed to account for the wild ups and downs of the internet space. As if that wasn't a difficult enough task using traditional infrastructure, blockchain presents a new kind of roadblock: consensus. Blockchain is designed such that all parties to the system must agree that any new actions, like say a money transfer or a software update, are legitimate. Consensus is a beautiful solution for decentralized security, but potentially problematic for app developers who need to make fast changes to properly scale their platforms. Bitcoin was the world's first glance into how consensus and scalability can become opposing forces. It has led to what some have called an ideological battle for the future of Bitcoin. That battle has remained yet unsolved to this day. The essential problem is this: the average time it takes to close a new block along the Bitcoin blockchain is around 10 minutes. The maximum block capacity is 1 megabyte of data. This means, realistically, you can only expect up to 6 megabytes worth of Bitcoin transaction data to be processed per hour. 1 megabyte is, of course, not a whole lot of data to warrant such a long processing period. Really, though, in our age of high-speed internet, the notion of 10 minutes waiting time for any online transaction is a bit unusual. Imagine if it took you 10 minutes to send your friend $5 on Venmo. Imagine if you clicked like on your friend's Facebook picture, and then Facebook took 10 minutes to register that command. The word for this is latency, or the amount of time that it takes a network to process a single transaction. But what if I told you that 10-minute latency problem, haunting the very future of the Bitcoin platform, is actually a solution? Latency is a security feature which prevents invalid transactions from being successfully included in a blockchain. Here to explain how this works is Oded Noam. Oded is a blockchain architect. In other words, the type of person who designs decentralized platforms and has to deal with latency firsthand.
If you just take the Bitcoin network, create a duplicate network that operates exactly like Bitcoin, but closes a block every 10 seconds instead of 10 minutes, then you're going to have a lot of forks, which is the technical term for conflicts in data between different nodes. So when you have a lot of forks, it makes it easier for an attacker to create false data on the blockchain.
Perhaps you can see now why rate of transactions, or throughput as we call it, is such a barrier for blockchain platforms hoping to accommodate the wider business world. On one hand, major market apps see huge levels of transactions per second, and in 2018, latency is simply unacceptable to consumers. Think about a fast-growing app which needs to be able to accommodate an influx of new users while not disappointing them with performance issues. On the other hand, delayed transaction time is actually built-in security feature necessary to prevent messy blockchains littered with double spending.
In essence, the latency of the Bitcoin network comes in direct trade-off with the security of the network. And so Bitcoin chose to resolve that by selecting a very slow or very high latency walking point where they're closing a block every 10 minutes in average. And of course, that's not practical for a lot of applications that we're considering nowadays.
When it comes to designing apps for scale, scaling up or down, or just dealing with a large-scale user population, getting throughput right is essential, but it's not the only engineering issue developers face. One of the considerations that any business, digital or physical, will face when scaling is fees. If you own a popular coffee shop, you may want to open up more store locations to build out your business. Doing so, of course, will incur a range of new expenses. More employee salaries, rent, supply, as well as the one-time costs of furnishing and gearing up the store. In the app space, the same principle applies. An app rising on iTunes top charts will require more and more storage and computing resources. On a platform like Ethereum, though, customer acquisition fees rise in proportion to the size of an app. A newly launched app might start off by paying 5 cents per user, but end up paying $10, even $100 per customer if the app is reaching millions. This essentially de-incentivizes growth and makes it unreasonable for large-scale applications to enter the space. Imagine if Snapchat had to pay $100 per new account. It simply would not work. And that's on top of all the other fees associated with running a business. It's enough to bury a hot startup app under the weight of its own success. Here's Leonid Beder, whom you've already met this season in our episode on the third generation of blockchain.
In Orbs, so not only, we're already, I think, past the point that throughput and latency, is going to be very desirable. Transactions per second and the smart code that they're going to develop and the cost of this going to be extremely, better compared to traditional, blockchain solutions such as Bitcoin and Ethereum. But we're also solving, this kind of problems, the problems of churn, the problem of fees, security.
Fee models can be a tricky problem for apps looking to scale, partly because of the nature of how consumers tend to interact with the apps they use. But in mentioning processing fees, Leonid happened to bring up another important, yet much less heralded, problem in the app world: churn, or the pace at which users slow down or altogether stop using a given app in a given time period. Churn rate isn't a phenomenon unique to the digital world. A hot new coffee shop hosting a grand opening event might spend a certain amount of money per invitee, but there's no guarantee that many of those individuals will become regular customers, or that their enthusiasm for the coffee won't wear out over the following few weeks. What we're talking about here is efficiency of retention. Not getting new customers, but keeping the ones you've got. Because the app space is notoriously fast-moving, though, it's not uncommon for apps to end up with only, say, 5% active user populations. Sure, at the beginning it might seem like the sky's the limit. Then, a few months down the road, some new app draws everyone's attention in that direction, and so on and so on. Churn has implications that affect how an app chooses to use its resources. On one hand, all users must be accounted for. Shutting out 95% of a user base just because they're inactive would be like barring anyone from entering your coffee shop who hasn't bought at least 5 drinks in the last month. On the other hand, if only a small percentage of users are active in any given month, it's not practical to bend over backwards accommodating all those people who aren't going to use the resources spent on them.
Let's say, that in Ethereum, if you want to onboard a new user to the system, same goes, like for blockchains like Stellar and or NAM, you actually have, to fund their account. You need to spend, some Ether in order for them to be able to perform some transactions. But the problem is, so what happens if you're going to fund this way 1 million accounts and, pay lots of money in order to do that, but you're going to have only like 10 people of those actually going to use the system. So the churn problem, can you get those funds back? If you can get those funds back, is very, very complicated. And it's, so even if, for example, in Ethereum or Stellar, even if performance will be great, you still have, for example, this kind of problem, this kind of governance problem. And so many people won't be able to afford it.
And then there's one more complication: fluctuation in network access. To get an image of what I mean by this, picture a Major League Baseball stadium. On any given day in the 162-game season, the stadium is unlikely to sell to full capacity. It's not easy to get fans excited about Game 53 out of 162, or 54, or 78, or games in the rain, or matchups against weak competition. The stadium is only built so big to accommodate those games that do sell out: opening day, weekend rivalry matchups, and the playoffs. Similarly, a website for a news organization might see predictable traffic throughout a given week, then a huge uptick when some breaking news is reported. The same occurs when a streaming site runs a big sporting event, or when a new season of Stranger Things comes out on Netflix.
Blockchain.
Different types of infrastructure providers have varying degrees of accommodation when it comes to dealing with churn and network access fluctuation. In the blockchain space, though, these problems are yet unsolved. When an app running on Ethereum tries to accommodate very high traffic, transaction fees become unreasonably high. Plus, the entire network, that is, every other app running on the platform, is liable to slow down as a result of the bottleneck. Bitcoin and Ethereum both experience backlogs when the volume of transaction requests at a given time outpaces the network throughput capacity. I spoke with David Yakira, a blockchain researcher who you'll be hearing from again later this season, about how to model a problem like network usage fluctuation. In other words, what will a future blockchain solution here look like?
The idea is that they would be able to throttle their resources as demand goes up and down. Let's look at Bitcoin, for example. Bitcoin has a pretty steady block rate. Every 10 minutes there's a block, and it has a limited or a bounded size, right? It's a 1 megabyte block. And so it doesn't matter what the demand is, there will always be a cap on the throughput that we're able to process with Bitcoin. On the other side, there are platforms like AWS where if you are running an application on AWS, you can kind of throttle the amount of resources that you have according to the amount of demand and the amount of requests that are coming to your application. And I think this is the right approach, and this is the approach that we're trying to kind of implement in Orbs.
In speaking with me, David also describes how the platform he's working on uses incentives to mitigate scaling issues by organically motivating nodes within the blockchain to handle network traffic without delay.
If you're one of the nodes and you see that the demand is going up now, and you are supposed to, to get more resources, and you don't do that, then you're going to be behind. You're not going to be able to keep up with the network, and then the reputation measure quite fast is going to catch you. Is going to see that you're not doing what the protocol instructs you to do. So if you have a low reputation, then you're going to get less fees for running the platform. So your incentive is going to be to throttle, to keep up with the demand.
A blockchain infrastructure for the app universe will need to improve on previous models by providing a workable solution for apps experiencing variable user activity. The key here is to allow developers the ability to scale without incurring unreasonable fees and without threatening the health of the network overall. Of course, there are no easy solutions to blockchain scalability. If there were, I wouldn't have spent the time and effort writing a podcast episode about it. You can ask a dozen industry experts how to fix throughput and latency, churn, network usage rates and fees, and each person will give you a different answer. How do I know this? I spoke with those industry experts, asked those questions, and got those answers. In the end, it seems we'll just have to wait and see what ideas rise to the surface, what the smartest minds can build, and what ends up working for larger marketplaces.
The main thing that holds us back is time.
You're now listening to Eyal Herzog, co-founder of the video sharing website MetaCafe and founder of Bancor, a cryptocurrency exchange.
It's an evolution, and it's an evolution that takes time because every blockchain essentially is a consensus between a large group of people. That's what it is. It's an agreement. So whether that group of people are running Bitcoin or Ethereum or whatever, that's what it is. And this agreement takes time to form. So, I heard about Bitcoin 2011, which was really early, but Bitcoin was released in 2009. Very few people heard about it. And, it took Ethereum a long time to take off and to build up. And I think we will see every technology inspiring the next one. It's just like it was with the Palm Pilot that probably inspired the BlackBerry, that probably inspired iPhone, which inspired Android. So I think we will see the same thing. We will see existing technology inspiring new technologies, and the new technology is going to be bigger, better, faster, and learn from the mistake of those who came before them.
That'll be all for scaling applications on blockchain. I hope you've learned something in these past 20 minutes or so, and I thank you for listening. If you have questions or comments, email me at nate@podil.net, and stay tuned for the next episode of the Orbs podcast.
Blockchain.